Hi friends, today we will discuss about Python programming language. We'll learn installing it, we'll get started with software as well as write first program and explore important constructs. So Python is a programming language. It is now the gateway into the world of big data, machine learning and artificial intelligence. Virtually all of the most important deep learning frameworks are Python based, and Python is also the language of choice for those who are new to programming. This video series is for anyone looking to begin their journey as programmer. So before we start with Python, we need a distribution, software distribution, which assists us in install Python on our machine so that we can go ahead and code. So for that, we have a package named Anaconda. So what is Anaconda? Anaconda is an open source distribution of the Python and R programming languages. Open source means they are completely free for any developer to download and use. So here we'll not focus on R programming language. Just to brief you, R programming language is a language which is generally used for statistical computation and data mining. We'll focus on Python language only. So when we use the Anaconda distribution, not only do we get the Python programming language, we also get a package Conda. Conda is what is termed as package manager. This helps to manage dozens of libraries that you can use to solve common problems. The package manager is what allows you to install the libraries easily. Let me give you a brief. Library is a collection of functions and methods that allow you to perform many actions without writing your code, like SciPy, NumPy, that contains script code to perform scientific computing and technical computing. Simply type in onto your browser window, install Anaconda on Windows, and this will bring up a number of hits on your favorite search engine. Click on this link. Here we are on the install page. Observe that the Anaconda distribution can be installed on any operating system. So we'll be taking here Windows operating system. If you have a different operating system, you can simply select the link of your OS. I'm going to select Windows. Click on the link which says download the Anaconda installer. This will take you to the install page, which should automatically detect your operating system. But sometimes that doesn't really work. So I'm going ahead and select my operating system. I'm going to select on the Windows tab, which will give me the right software for my Windows machine. Select Windows operating system. All of the programs that we will write in this course and on other courses in the path will use Python 3. With this in mind, let's go ahead and select download button here for Python 3.7. You can select where you want this exe file to be located. Once the executable to install the Anaconda software on your machine has been downloaded, you can go ahead and open it up and start the installation process. And this will bring up the really simple dialog where you simply follow instructions on this dialog in order to get Anaconda and Python set up on your machine. Click on next through every screen. Make sure you agree with the license agreement. Click on the I agree button here and move on to the next page. Now your machine might have multiple users. Here is where you make the choice of whether you want this Anaconda distribution and Python installed for all users or only for yourself. If you install for all users, you need to be an administrator on the machine. I'm going to select all users. Click on the next button to proceed with the installation. So decide where the destination folder for this installation should be. If that is okay with you, click on next once again and move on. Now you might have other versions of Python installed on your machine. If you click and select this checkbox, this version of Python that we are installing using Anaconda will be the version that applies by default. So I'm going to select this checkbox and click on this install button. And now just wait for a few seconds till the installer does its job and complete the installation for Anaconda distribution machine. Click on the next button. This will show you the option for additional software packages that can install on Windows. We are only focused on Anaconda and Python, and let's move to the next page. And here we are at the end of our installation. You now have Python on your local machine. Click on the Finish button here, and you have successfully installed and set up Python using the Anaconda distribution. Now to interact with Python, you need to bring up the command prompt on your Windows machine. Use the Start menu or the search option to bring up the command prompt. You can confirm whether Python has been installed successfully on your machine by simply running the command Python. Notice that the prompt has changed. You are now within the Python interpreter. Now that we know that Python has been installed successfully, type in exit and get out of the Python shell. This is not where we will be writing our Python code. We will use something simpler. Base, active base is the name of the default variable environment. So when we type here command active base, it just creates a virtual environment. You don't really need to worry about the nitty-gritty details of what a virtual environment is, why it is needed, and so on. Just remember that this will allow you to work with Conda package manager and work with Python and bring up Jupyter Notebook. So let's deep dive about what is Jupyter Notebook here. What exactly it means? Well, this is the interactive shell that we will use to type out our Python code. So Jupyter Notebook we will be using as integrated development environment, that is IDE. Jupyter Notebooks offer a browser-based interactive shell where you can type in your Python commands within cells, execute those cells, and see the results of your execution there within your browser. If you type in the Jupyter Notebook command, this will bring up a URL that should automatically open up within your browser tab. If it doesn't, you simply copy paste this URL onto a new browser window. You will have to leave this command prompt open and have this program running. This is the Jupyter Notebook server, so do not kill or close this command prompt because you will need this to work with Jupyter Notebooks. When you are done programming, you can kill this command and close this command prompt. This is the home page for Jupyter where we will create what are called Jupyter Notebooks, where we will write our Python code. The files that you create using Jupyter Notebooks will be automatically saved within your current working directory or your current folder. These files are referred to either a Jupyter Notebook or IPython notebooks. IPython is an older name which is still often used. In order to create a new notebook, you need to click on this new menu drop-down to the top right of your screen. Click on New. This will bring up a menu and you can select the Python 3 option. Selecting Python 3 indicates that the notebook will run on the Python 3 kernel. This will open up a new notebook on a new tab on your browser. and this notebook will automatically get the name untitled. Select the current name of this notebook, that is untitled. Click on it, and this will bring up a little dialog, and then you can rename this notebook by writing any name of your choice. Let's say you want to call it my first Python notebook. Click on the name button and you will find that your notebook name has been updated. You are now ready to get started with coding. This little box that you see here on screen is actually a code cell, and you type in your code within this little box. And then you hit Shift plus Enter in order to execute this command. Shift plus Enter will execute these commands, print the results on screen, and it will also create new code cells if needed. You can also type in your command prompt commands within your Jupyter notebooks. Make sure that you precede these commands with an exclamation point. This will tell your notebook that this is not a Python command, instead it's a shell command. So we have Python command that we can write like to know the version of Python. So we have a command to know the version of Python. We can write exclamation Python dash dash version. This will print out the current version of Python that we are using. So now let's see how Python can be used as a calculator. You can also use this plus button here in this Jupyter Notebook menu in order to create code cells. Click on plus multiple times and a new code cell will be created each time. These are the code cells where we will create or we will write our Python code. Let's type in some simple Python code. I want to calculate 7 plus 9, so I simply type in 7 plus 9 and notice that when I hit Shift plus Enter, I get the output right here on the screen within my browser window. The result is 16. Even though you aren't using any Python specific commands, what we have exactly executed is a bit of Python code. Let's try this once again. 20 plus 47. Hit Shift plus Enter. The result is 67. You can include floating point values in your calculation as well, such as 27.5 plus 9.4 plus 2. Python supports subtraction as well as division, multiplication, and so on. So 17 minus 10 will give you 7. Obviously, these arithmetic operations will follow the BODMAS rule that we learned back in middle school. Bracket will be evaluated first, then division and multiplication, and then addition and subtraction. You can also power off operation in Python, and the way you indicate this is by using the double asterisk signs. This is 10 to the power of 2, which gives us 100. Let's try this once again so that you can get familiar with it. 2 to the power of 4, which is indicated by the double asterisk sign, will give us 16. Division operation can be performed using the forward slash. Here the forward slash indicates that you want to divide 10 by 5. 10 is the numerator, 5 is the denominator. Observe that the result here is 2.0. In the case of division operator, even though both of our input numbers are integers, the result is floating point. Floating point is something which is fractional number or decimal numbers. If you are only interested in the integral result of division, integral result means whole numbers like 1, 2, 7, 17, numbers without decimals. So if you are only interested in integral result of the division, you can specify a different kind of operator, and that is the double forward slash. The double forward slash has calculated just the quotient of the result. It has entirely ignored the fractional part of the remainder. And as you might imagine, just like you can calculate the quotient, you can also ask Python to give you the remainder of a division operation. And this you do by using the percent operation, also referred as the modulo operator. So the 50 modulo 4 here will give or divide 50 by 4 and give you the remainder as a result, which is 2. Once you start programming a lot more, you will find that modulo operation is very useful for various numeric computations. Let's try the modulo operation once again. This time we will divide 50 modulo 5. This is an even division. There is a no remainder, and that is why the result here is 0. The remainder is 0. You can perform more complex operations, include the operations that you want perform first in bracket. Remember, the BODMAS rule has been followed in every case. You can perform the multiplication operation where a string is involved as well. Here, the string is hello Oliver, which is just a sequence of characters and which is enclosed in quotes, double quotes. In Python, you can use both the quotes, single quotes, as well as the double quotes to enclose a string. Here you multiply the string hello Oliver by a number 3. Python basically interprets this to mean hello Oliver 3 times. The result of this multiplication operation is the string concatenated 3 times, and the result is also a string. So let's discuss about Python built-in functions. So what exactly are functions? Functions you can think of as a reusable bit of code, and this can be code to perform a calculation, a useful action, anything. For example, you could have a function to add two numbers. If you were to type in a string using double quotes in your code cell, here on this Jupyter notebook, the Jupyter notebook will simply write out the string in your result. A function has a name and it is invoked using brackets. Now that we are passing in here, the string hello Oliver is an input argument or an input parameter to the function. The input parameter is what the function needs, information that the function needs to perform its job. Developers of Python programming language have already written the code to print the information that you pass into the function out to screen. You are just invoking the print function and using their code. So when we invoke the print function in this manner, it prints out to screen hello Oliver. Strings can be defined using double quotes in Python or single quotes. So you can invoke the print function and pass in hello Oliver in single quotes, as well as the same hello Oliver will be printed out to screen. Observe that in both cases, when the print function printed out the string to screen, the quotes for the string were not included. Python only prints out the content of the string, the content that we passed into the print function. Now, you cannot work with the strings without the quotes. Let's say I were to invoke the print function and pass in hello Oliver without the enclosing single or double quotes. This is an error. And Python will tell us that this is invalid syntax. Syntax basically refers to the structure of command that Python understands. You are working with Python 3. Always use the brackets, the print function to print stuff out to the screen. We can move on to another built-in function in Python, that is len function. The name of the function is len, L-E-N. It's invoked using bracket, and the input argument that we pass into the len function is hello Oliver, the string. When you pass in a string to a len function, the len function simply counts the number of characters in the string, and in our case, the number of characters is equal to 13. Observe that the code that was executed by the len function is different from the code executed for the print function. The len function calculates the length of what you pass in. The print function prints out what you pass into the screen. We will now use the print function in a slightly different way. Say print 5 plus 4. What does Python do? Python will first calculate the result here. 5 plus 4, Python knows is 9, and it will pass in 9 to the print function. Let's say you call print. Within the print bracket, you specify a complex calculation. The result of that calculation will be calculated first. That result is passed into the print function, and the print function will simply print the result out to screen. The absolute function, or we can say ABS function, here, which calculates the absolute value of a number. The absolute value of 17 is 17. Let's use abs function once again with minus 17. The absolute value of minus 17 is 17. Just like with the print function, you can pass in the result of a computation to the absolute function as well. So Python will first compute 4.5 minus 2 asterisk 4 plus 7. The bracket will be evaluated first. Once the result of this entire computation has been calculated, the result is passed into the absolute function, and the absolute function will calculate the absolute value of that result, which in this case happens to be 17.5. So we will keep our learning up to here only in this video, and in our coming next video we will move further and focus on learning Python scripting language, so that we can develop insight in scripting programming part as well, and strengthen our development skill to understand artificial intelligence and machine learning from programming aspects and at implementation level. That will broaden up our understanding of machine learning and its implementation in our daily life. Thanks for watching this video. See you all in the next video. Till then, goodbye.